Okay, we are taking a peek today at the quiz preview for our next quiz, dealing with our adding, subtracting, simplifying, multiplying, dividing with fractions. So we're going to start up here at the top with a couple of general questions to think about. When referring to rational expression operations, if you're adding, subtracting, multiplying, or dividing, when do you need a common denominator? When you're adding or subtracting. Multiplying and dividing, we can go straight across, we can cancel, whatever. But adding and subtracting, we got to have that common bond before we get started. That's all I need for that one. So then, when trying to simplify any rational expression that involves quadratics, what should be your first step? Whether it's multiplying, dividing, adding or subtracting, it always needs to be, can I factor anything? Because oftentimes, if I factor, I can either cancel if I'm multiplying or dividing, or it helps me to build my LCD if I'm adding or subtracting. So that has to be it. It's kind of our golden rule here. As we start getting into some of the actual work, what are the least common denominators? Notice we're not solving. Just what's the LCD? And as we've talked about time and time again, it's usually a wise idea so you don't go canceling stuff you can't. When you see plus minus, we're just going to put those in there. So here, when I'm rolling down my LCD checklist, I don't have any coefficients. I don't have any random exponents sitting out here on a variable term, so I don't have like x or x squared or something. But I take each unique quantity and make it part of my LCD. And that's it in this case. If I'm doing it on this one, again, just think about it for a minute on the three parts that we are working. And if we need a little bit of a reminder, let me move this up a little. We'll get ourselves a reminder in here. Okay, do I have any coefficients? Yeah, I have 1. I have 4, so that can be part. Do I have any single variables? I guess I should have written in here. Use the one with the biggest exponent. I only got 1. That's my LCD. Not building them, not doing anything else, just writing them out. But like we mentioned before, our first step is always, and it should be right here, if I can factor my denominator, and sometimes it may be neither, sometimes it may be both, but if I can factor that, I need to do that first. And then when I go to build my LCD, I just use the unique parts. Now again, I know you see x plus 8 twice, but I don't use it twice. I don't make it squared. The only time we do that is if we have the squared in an individual problem on this. Okay, so no squaring there. Move this back out of the way. Okay, if possible, simplify. We're always looking for something that we have in common somewhere or something we could factor. These both have an x. And then again, once there's no parentheses left in a portion, the bond is weak. I can't even see it with a multiplication bond. So I can use my rules for for dividing with exponents and say 2 minus 1 is 1. My larger exponent's up in the numerator. Or we talked about how you could write out the x's and then cancel, but again, knowing our rules is usually a better way to do it, and my exponent will always end up where the larger one's at. Okay. Cannot cancel these. Again, this is in parentheses. That's why I put them there, so I don't forget about stuff like that. Here, looks like we might be able to factor both of these. I've got a difference of squares. Now down here, I'm going to have to do a little mental math, maybe some slide and divide. But again, here, do I really even need to do my slide and divide? Let's think about this for a minute. What multiplies to 2? 2 and 1. What multiplies to 7? Well, 7 and 1 does. But I notice a couple of things. I notice this plus means either both signs are negative or both are positive. Well, how do I figure it out? Right here. If the sum's negative, these both have to be negative. And I need to make sure when I FOIL it out that it multiplies to negative 9. So if I were to do like 7 and 1, well, that wouldn't work because it's negative 14 and negative 1. That doesn't work. Let's try 7 and 1. Negative 2x, negative 7x. And again, if this is something that you're not comfortable with doing the mental math, you can take a quick step if you need to do a slide and divide on this one. It's not one that's real tricky. You're like, okay, multiplies to 14, adds to 9, 7 and 2. They're both negative. Divide back through by my 2, and I see where this ends up coming from. 2x minus 7, x minus 1. And then I cancel out the parentheses that are identical. Get my answer, I'm good to go. We talked about with monomials. If you have those, the easiest way to go is just to multiply straight across. And again, when you're multiplying, you add the exponents. Now I'm going to assume at this point that a lot of you on the 192 over the 190 are just going to go ahead and use math enter. And that's a fine strategy to use. We want to keep things as simple as we possibly can. So what we'll do here in a minute, there we go. Because I do need to reduce. So 48 for 25. I notice there's only one x term, so it'll stay on the bottom. But then my y's, 5 minus 1 is 4. Larger exponents up top in the numerator. Circle that, and I'm good to go. So as I'm doing all of these, there's just little things to watch for. Divide, remember, means those flip. Difference is squares, and this is a point where you need to start recognizing those. If you've put off factoring, put it off, and now you're kind of throwing up your hands, I don't know what I'm going to be able to do for you. Because now once I get those moved around, I'll cancel what I have in common. I'm usually a fan when I get to this part of rewriting what I have. And then I can look and say, oh, I have x's there, so I'm dividing. So I'll subtract those. 6 minus 4 is 2. Larger exponents in the numerator. And then the 4 and the x minus 6 are down here. Again, can't cancel the x's. They're locked into the parentheses there. That's as far as I can go. So again, with division, make sure that second one gets flipped over. Again, my suggestion to most of you is going to be to multiply across. And then allow ourselves to swing this over. So we've got 3/8. 5 minus 4 is 1. Bigger exponents in the denominator. So we're getting to combine exponent rules with our factoring rules when we're working on these. Again, in pieces, I would rewrite it. When I'm multiplying, everything else is a fraction. I'll make this one 2. And my last one is going to flip. And again, if I see plus or minus, I'm going to put parentheses around it. But I notice when I'm flipping and taking the reciprocal of my last fraction, hey, that's a difference of squares. 2x minus 5, 2x plus 5. So I've factored. I did my reciprocal. Now I'm going to cancel the sets of parentheses that are identical. Only got an x left on top. This guy left on the bottom. That's the best I can do. Okay. But always cancel and just multiply across. But the big key is don't try to make the canceling where you can't. Add or subtract. Don't forget you need a common denominator. Okay, so I kind of get this out to remind me here. So when I'm looking for my LCD, again, parentheses whenever I see plus or minus. Oops. So here, I don't see any coefficients. There's no numbers hanging out in the denominator. I don't see any variable terms down here. But I do see a couple of sets of parentheses that are going to be the basis for my new LCD. And again, like we did before, my goal is to see what do I need to get from here to here. Well, I already have the x plus 3. I still need the x minus 2. Over here, I already have the x minus 2. I need the x minus 3. And that, to be perfectly honest, is the hardest part of this whole thing. Because now, all I've got to do is some distributing. And again, if you feel comfortable doing the combining up in the last step, that's fine. So I've got 6x minus 2 and I always, if I can still factor at the end, I want to do that just to be sure if there was some other little thing I could cancel, oops, minus 2, that I could. And again, the nice thing if you're watching this at home later, you can pause me in different places if you need to, because I just want to make sure we get all the information here for you as we're working through these. So look at that one separated out. Here, again, keep working on those LCDs. Look for coefficients. 5 and 10. If just 5 and 10 were my denominator, what would my LCD be? It'd be 10, because if I start counting by 5s and 10s, 10 is going to be the first number that shows up. Are there any exponent terms? Yes, there's an x. No parentheses this time, no quantities. So 10x, 10x. How do I get from here to here? 5 times what gets me to 10? 2. And I need the x as well because it wasn't up here originally. So 5 times 2x is 10x. Hey, I got everything I need in the second one, so I don't have to do anything. Okay. So multiply those together. Always look at the end to see if there's something that might be able to be factored out. And then the cool thing, because every once in a while this happens, I can get to a point that I can go, hey, look, 2 goes into 10 5 times. So I can give that a little bit of a reduction. Two goes into 10 5 times, and now I'm done. Lots of detail work, especially if there's some factoring at the start. Quick diamond, multiply to 14, add to 9 is -7 and -2. So my LCD is going to be x minus 7 and x minus 2. I don't need 2 of them though. So I look and I go, okay, first set of parentheses, or my first fraction, excuse me, I have everything already. Everything checks off, so I don't add anything. My second one, I have the x minus 2, but I need the x minus 7. And now I'm just going to go into simplify mode. I'm going to distribute my 2. copy my denominator. Let's see here, 7x minus 15. Nothing's going to work with that. And I'm done. Okay, so it is rare that I'm going to get something at the end that'll cancel, but you never know. That's why we got to go ahead and do that. These next couple, sweet, common denominator already. Love it when that happens. So you're like, okay, 6x minus 36 over x minus 6. Woo, I'm done. Careful. Can I factor my numerator? Yes. Oh, check that out. Check that out. This might be better than the eyeball. Whack those sixes. And all I'm left with is 6. And I'm good. That's why you always have to, once you get it down to one fraction, you need to see again if anything's factorable or able to be simplified. 11, I want to give one hint here at the start. Some of the classes I talked to this about, other ones I didn't. When I get a minus in the middle, especially if there's something going on over here, I'm going to move that minus up to the top, and I'm going to turn this into plus, just so when I go to distribute, I don't forget about it. I'm going to factor my denominator. Then I'm going to look and say, okay, my LCD is going to be x plus 3 and x plus 4. Again, I don't need the squared unless this would have been like x plus 3 squared when I factored. So write that down. Get my 8. Get my negative x squared minus 6 going here. Original to new. What's missing? X plus 4 it is. Original to new. What's missing? Not a thing. Going to distribute. I'm going to distribute that negative through over here. Watch it to get that plus 6. It's the little things that can get you sometimes. And then I'm just going to rewrite these in order from greatest to least. And taking a quick peek, I kind of see this isn't going to be factorable. So I'm done. Don't cancel x's. Parentheses. Don't do it. So you start to notice the key here is your LCD. Once we get that built, then the rest of this basically becomes Algebra 1 type stuff. And that's what we've got to be on the lookout for. So now, we're going to take a peek here. Notice we're going to whack the perimeter on this one, because that's one thing that we haven't talked about much yet. Yeah, we haven't talked about any of these, but we're going to make an application. If a rectangle has a length of 12 over 3x minus 6 and an area of 4x plus 40 over x minus 2, find the following. Find the width. You're like, what? Okay, think about a rectangle. The area equals the length times width. They told me the area. They told me the length. And my job is to figure out what the width is. You're like, how am I going to do that? Well, let's think about this for a minute. If I want to solve for the width and I'm multiplying it times this, what's the opposite of multiplying? You're like, divide. Okay. So I have 4x plus 40, x minus 2, and I'm dividing by 12 over 3x minus 6. Now it looks kind of more normal. You just had to think about it for a minute. You're like, okay, so what am I going to do now? I'm going to go through, I'm going to do my factoring. I can take 4 out. Remember, when I divide, I'm flipping those guys. So this guy is up top. I can take out a 3. And now at this point, back what we have in common. Maybe multiply across just to see where we're at. Ooh, 12s are the same. They're not locked in with anything. And I find my width. Now, I'll let you know, again, I'd hope with a rectangle you know that area equals length times width to be able to figure this out. But set it up. Don't freak out. Because you notice as soon as I knew the area, and then I knew the length times the width, I just put the pieces in and then solved it like I would anything else. Does it look unusual? Sure. Is it something we can't handle? No. These story problems are the type problems that are going to show up on standardized testing, so we've got to kind of get you used to this stuff a little bit. Brenda's workday totaled 6x plus 10 over x times x minus 2 hours. And her breaks added up to 2x minus 5 over x times x minus 2 hours. Write an expression that represents the time she was actually working. Okay. Here's the total amount of time she was at work. Here's her breaks. If you take the total amount of time you work minus the breaks, that equals how much time you'd work. You're like, oh. So basically, you just gave me a story problem to tell me to do this, because if I do total minus the breaks, I figure out how much time she actually worked. Correct. Nicer thing, I even have an LCD already. This is great. Like we did on the other problems, when I get minus, I'll put that up here to remind me that distributes through. The parentheses will help me distribute all the way through. So nothing fancy on the first one. Here I've got to distribute my negative. Combine like terms. My parentheses aren't the same. That's as far as I'm going to be able to go. So again, nothing terrible. Just making you think a little. Last one. Jojo simplified the following incorrectly. Identify your mistake and correct it. Now, if you wanted to on this, you could just run this problem yourself on the side and then see where the problem is and be like, oh, it's this. Probably what I would suggest doing, because Jojo seemed to do it a little bit differently than we do it in class. So I look and I'm like, okay, my LCD, I have my variable term, and I have a set of parentheses. So let's see if I do it next to Jojo's here. What was Jojo's issue? And again, that minus, move it up, change it to plus. And now we're in builder mode. So I look and I say, okay, I started with x. I want to get to x times x plus 2. I already have the x. I need the x plus 2. Second one, though, I already have the x, and I already have the x plus 2. Sweet. So here I'll distribute. So I've got 3x plus 6. And distribute my negative, negative x plus 3. And we'll combine like terms and see where we're at here. Doesn't look like we're going to get anything to cancel. So I'm like, okay, now what happened differently? 3x plus 6 minus x, ooh, minus 3. It looks like Jojo, when the negative was going through, didn't think about it. Why? Because she wasn't, or he, I'm not sure, Jojo could be either, to put those parentheses in. Because if Jojo would have put the parentheses in, that would have been plus, and then that would have been 9. Okay. So that's a good way for me to do it. I could always go back, do it myself, and then see where Jojo's issue is and fix it. So that's a basic look at what the quiz is going to be. So again, I'm going to throw some things in there to make you think a little bit on the back. But with the time we've spent, just kind of keep working, but go slowly, okay? Take your time with this, and I'm sure things will go fine.